A few days ago, I was watching Tom Sanladerer's video about FreeCAD. No surprise, there was a certain amount of rancor on the internet, but hey, it's the internet. There's probably an RFC that requires it somewhere. But stepping back a moment, I can't really say he was wrong. FreeCAD does have some infelicities, and it does do some things a little bit differently than other CAD programs. This can be confusing to someone just switching. So I thought I would show the FreeCAD way of doing a few things he was having some trouble with, and why something that seemed like it should work didn't. And of course, how I would design the part the FreeCAD way. In his video, Tom gave us an example design which appeared to be a seed pot which is split in half and held together by a ring. This is to make it easy to sprout a seed and then remove the root ball without damage for planting in a larger pot. But once he got the pot itself done using an offset of a revolve, he ran into trouble splitting it. Of course, FreeCAD can easily enough split a solid, it just does it a little bit differently than Fusion 360 or SolidWorks. So we'll start there. I'll just draw a quick sketch showing the profile of the pot. I'm not going to bother constraining anything because this is just an example. Now do a 360-degree revolve, giving a basic pot shape. But of course it's just the surface. So I'll offset it to 2 millimeters. Now because we want to make a solid, we'll click the Fill Offset box. You'll notice as I click the box, FreeCAD automatically creates a ruled surface between the lip of the inner and the outer surface of the cup. This will become important later. Once we OK it, it'll auto-convert that to a solid. We can see the face that was created by the ruled surface in the solid. Now this cup is supposed to be split, and that's where Tom ran into the first difficulty. In FreeCAD, we often create geometry to use as a tool to work on our final part. In this case, we're going to create a primitive plane. The primitive plane is really just the surface. It has no thickness to it whatsoever and is meant to be used as part of something else or as a tool. We'll make the plane 100 by 100 millimeters. There's no precision involved here, it's just going to be a rough tool and all we need is for it to be bigger than the cup. By default, the plane is on the global XY plane, but in this case we need to split the cup in half. So we'll go down to the axis of rotation and set it to rotate along the Y-axis and to rotate at 90 degrees. I'll just tell it to create and move our viewpoint around so we can see the face of the plane. Right-click the plane and select Transform to move it into place, bisecting the cup. Now we select the cup and then select the plane and go to Part, Split, Slice Apart. We can open up the exploded slice and see that we have slices 0 and slice 1. I'll hide everything and bring it back one at a time to show what we ended up with. As you can see, this is the split we want. Some may find this method of splitting things a little bit cumbersome, but if you watch my other video, Making Tools to Make Things, you'll see that it's quite versatile and can be used to make much more complex splits in an object. The next thing Tom tried was simply doing a 180-degree revolve and then offsetting and filling in order to make half a cup to begin with instead of splitting. This did not go as well as we would have hoped. He offered the opinion that really the filled offset should have worked, and he's absolutely right. It seems like it should work. I'll delete everything back down to the profile sketch and show you what went wrong. We select the sketch and revolve, and this time we'll specify 180 degrees revolution. So far, so good. Now we select the revolution and go to offset again. We'll do a 2 millimeter offset, and for now I will not click fill because we know that's going to fail. I'll turn it around so we can see what's happening. As you saw before, when you click the fill offset, a ruled surface was created between the edges of the revolution and the offset. Here we can manually create those ruled surfaces just to see what's going on. I'll start with the one around the rim and work my way through. We filled in between all of the edges, but you'll notice here in the corners we have 2 spots where the shell is open. This is where the problem happens. We need a surface to fill in between the 2 lines and an arc. The part workbench doesn't have a tool for that, and that's why checking the fill box failed. The curves workbench does offer a tool for that. I've made that tool available from within the user interface of the part workbench using a custom toolbar, but it is still nevertheless in a separate module and not a standard part of FreeCAD. If you want the curves workbench, you'll have to install it from the add-on manager. Now I can complete the process that we would have hoped the offset would have done for us. Now I'll go to ShapeMaker and pick Shell from Faces. I'll use a box selection to select all of the faces and click Create. Now that we have a complete shell, we can go to Part, Convert to Solid. This is a case where we see the effect of a small development team with limited time and resources. At some point, the Curves workbench may become a full part of FreeCAD, which will make the Fill Boundary Edges tool available to the part workbench. Maybe it'll even be placed in the part workbench. But once it is, it'll be available to the Fill option of the Offset tool, and so it would be able to complete the operation for itself as we would expect. Just to prove the point, I'll take everything back down to the 180-degree revolve, select it, and choose Offset again, but this time I'll change the join type to Intersection. As a result of that, we get a sharp corner where we used to have an arc. As you can see now, when we click the fill box, the tool is easily able to add all of the ruled surfaces necessary to close the shell for itself. Now, just to belabor the point, I'll take it back to the sketch again. This time I'll apply the fillet tool to the corner. As you can see now, the offset matches the revolution feature for feature, and the fill box works just fine. So with that explained, it might be nice to actually design the seed pot. There are many possible approaches. This one is mine. I'll start with the profile as before and revolve it. Now I'll do an offset filled of 1 mm. This will form an inner shell of the pot. To keep things from becoming confusing, I'll rename it Inner. Now I'll select the revolve again and do an offset of 1 mm not filled. Then I'll select that offset and yet again do a 1 mm offset, this time filled. This forms an outer shell. Effectively, we have 2 1 mm thick cups stacked together. I'll rename this offset to Outer. Now I need cutting planes. In order to make the 2 halves interlocking, I will cut the inner and outer cups at different points symmetric to the center. Just to move things along, I'll just unhide the one we were using in the demonstration earlier. I'm going to adjust the position of the plane to -2 mm on the x-axis. Since I'm going to slice the inner and outer cups in different places, I'll make a duplicate of the slicing plane. To avoid getting confused, I'll rename the original inner plane, and I'll name the copy outer plane. I'll adjust the outer plane to +2 in the x direction. I'm being careful to give everything a meaningful name since I'm performing nearly identical operations on nearly identical objects. Without names to keep everything straight, it would be very easy to get confused. Now it's time to do some slicing. I'll select Inner, then Inner Plane, and go to Part, Split, Slice Apart. I'll rename the exploded slice Inner Slice to keep it straight. Now I'll repeat the procedure for the outer cup, naming that exploded slice Outer Slice. I'll hide everything away so we can see what we're doing. Now as you can see, we have inner and outer slices, each consisting of a left half and a right half. Now toggling the visibility to make sure I pick the right slices, I'll select the inner right slice and the outer right slice and fuse them together. I'll name the fusion right. Now I'll repeat the procedure for the left-hand slices. And there's the two halves of our cup. I gather from Tom's design that the next step would be a ring that fits over the cup and catches on the lip to hold it all together. But I think we have the idea now. So as you can see, FreeCAD is very much usable to complete your design. People coming to FreeCAD from Fusion 360 or SolidWorks will have some learning curve getting used to how the FreeCAD does things. And they'll find some places where they have to work a little harder than they might in their current CAD program. On the other side of the balance, the price for FreeCAD is certainly right. There's no rental, no chance the price will be raised tomorrow. Features will not disappear and your work will not end up locked away behind what has become an unaffordable fee. The weight of those things and so where the balance ends up will be very much an individual decision. If you're a large engineering shop paying professional salaries, it's probably not the right choice today. As expensive as licensing a seat for SolidWorks might be, it's nothing compared to the cost of the person sitting in that seat. If you're a sole proprietor or in a small partnership, especially if CAD is only part of what you do, FreeCAD starts to look a lot more attractive. If you're a hobbyist and CAD is not your day job, you really should be considering FreeCAD. You certainly don't need SolidWorks to design a few household or automotive items, a drone, or even a hobby robotics project. Personally, I've chosen to use FreeCAD. Even if FreeCAD doesn't meet your needs today, it's worth keeping an eye on it. It's made a lot of progress in a little time and continues to grow and expand. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.